Hello everyone and welcome to the Wednesday webinar from the Tekla Inc. Steel segment team. Once again, my name is Ian Coates. I'm the product manager for the steel team here in Atlanta, and I'm also accompanied as usual by Lee Snyder, our application consultant. For those of you who don't know Lee, he joined us from a detailing background, and he's now our resident expert in the steel segment team. We also have Brian Raglan working the booth as well, so be sure to say hello to him. You'll see him on the question and answer window. What we're going to talk about today is the start of a new series. We're calling it the Fabricator Series, a collection of webinars based around using Tekla structures in a fabrication scenario. So as many of you know, we focus very much on steel detailing, but also those guys further down the line from us, the steel fabricators, also benefit as well. So we're going to put together just a few topics here shown on screen based towards fabricators, and this is going to be the first of them. We're calling it like accurate estimating, but what we're going to do is we're going to take a model and go right through all of the different functions and things that you can do with a Tekla structures model in a fabrication workflow. Our next webinar is going to be Wednesday 13th July, probably 12 p.m. Eastern Time. It'll be the next step in this Fabricator series, organizing the model. Simple tools to classify and categorize your model objects for smoother extraction of data. Just a lot of fancy words that really says how to kind of simplify the model for use downstream. And also future webinars, we always advertise them on our website, www.tekla.com/us. You'll remember, of course, that we have the question and answer window, and many of you use this, and please, if you haven't asked a question already, don't be shy. Please jump in and just ask any question you like. We've got, like I said, Brian is going to be working answering those questions as they come in. The chat window is disabled, but that Q&A window will be able to communicate directly with us here. We'll make every attempt to answer all the questions that we have during the presentation, but we can't type very quickly, so if we don't get to your question, just feel free to go ahead and email us, or we'll try and reply to all the other questions as they come in as well. So you've heard enough of me for now. I'm going to hand over to Lee, and let's begin today's presentation. Lee.
All right, thank you, Ian. We'll go ahead and jump right in the Fabricator Series estimating. Basically, we'll create, talk about several ways to create a model that will allow us to prepare bids quickly and even on the fly. So what our objectives are for today, we'll just have three main ones that we want to briefly discuss. Is that we're going to talk about methods that a detailer or fabricator could use within the Tekla structures models to prepare bids. And this is part of a campaign that we have overall to help you guys win more bids. Basically want to help our users be able to get more work and be able to be more efficient with the tools that they have. Now, a thing to note is that this, what we're going to demo and talk about and things like that is not in any way intended to replace an MIS or MRP solution, but some of the things that you could use or could do can be used to help or to augment those solutions. So we're not trying to replace anything, but show you some ways that you can estimate within the model and use those in conjunction with other solutions if you already have those in place. So to begin our estimation process, what I'm going to do is just jump into a Tekla structures model that I have right here. Right now it's an office building that we're working on. This is the plan at level 2, so just the second level. And a couple ways that we can model things in is just the traditional way where we just come up here. I'll just grab the properties of this beam here, and I can just quickly model in just as we would. Just snap into these grid lines from left to right in between the actual columns.
So this would be the detailer or an estimator or something doing this, yeah?
Yeah, this would be the estimator or whoever's doing it that wants to just quickly input. You don't have to do it with a whole great down to the detailing level of things like that. We just want to quickly get things into the model so that we can quickly just run an estimation off of it.
So this would be like a takeoff from the drawings, just like instead of just highlighting them on the sheet and then writing them into a spreadsheet, you could do them as a takeoff and just put them into the Tekla model instead of just filling in values on a spreadsheet, right?
Right. Yep. So what we'll do, that's one way, just manually modeling everything in. But if you have a DWG or a DXF, or actually like an electronic copy of the drawing, you can bring that in and overlay it onto the plan, and then you can basically just trace around those lines. So I'm just going to come in here to File, Insert Reference Model, and we're going to select this office plan at level 2, just a DXF, and I can change the scale if we want, depending on what it's set to, but I'll just go ahead and snap this in. And what this is, if we zoom out, this is just the grids from an AutoCAD drawing with the actual members here. So these are the ones that I just added in. You can see the lines that I would snap to, and then the profiles. And we have a handy tool that will allow you to quickly model these in. Down here it's this fairly new snap to lines and edges. What I can do is, if I activate that and then bring in my tool command, I can just come in here and you'll see the arrow, the direction that it's pointing. So this is saying that this beam is going to be modeled in from left to right, just as we traditionally would. So I'll just click that and it instantly snaps in the beam. So I can do that in either direction here.
I guess another benefit of this, Lee, is that you actually see what section size it's supposed to be on that drawing, so you're not having to keep turning back and forth to the drawing beside you on the table, so that you can model it pretty quickly. Yeah. Yep.
You can just come in here and snap real quick to where those lines are. And another thing is, you don't have to look back at the spacing. You know, the ones that we've put in right here are straight on dimension lines, but or on grid lines, but I don't have to put in points or offset lines or things like that to figure out where they're going to be. I know where the exact spacing is based upon these design drawings.
I guess it's just down to how much you trust the engineer to make the drawing correctly to scale. Yeah.
Right. Yeah. Obviously, that's going to be the quality and the integrity of their drawing. So there's another way that you can do this. I'm just going to go ahead and hide this, and we'll talk about the next way. So this is the still down here that I've already put in. Now if you have an IFC file of the actual model or 3D model, you can bring that in and we can convert those into native objects within Tekla structures. So what I'll do is I'll just go ahead and I'll just go File, Insert, and then I'll find this partial plan right here at level 2. And this is an IFC file that's basically just going to be for reference. I'll set this back to 1.
Yeah, I mean we're both just back from the North American Steel Construction Conference up in Pittsburgh, and everybody's talking BIM all day. And this is one common format that we can see is very, very popular among software providers. This IFC format. There are others as well, SDNF and SYS2 for example. But this IFC file is really powerful in that you can bring it straight into the Tekla model and either use properties or, as Lee might show in a minute, convert them out.
Yeah. So what this is, what I'm hovering over right now is just a portion of the building. So this is the IFC file. Right now it's just purely reference, where I could come in and see like that, the outlines of the shapes and things like that. But these are being referenced from a location on my computer. They're not actual objects within Tekla until I come up and convert them. So I'm just going to window highlight this area right here, and we have a feature here to convert IFC objects. So I'll just go to convert IFC objects, and it'll load up this right here.
Yeah, I mean one of the things that you can do is that IFC format, because it's extracted from different softwares, it actually does have a range of property sets that you could even run reports on right there. You can get things like surface area, total weight, all of that information. But obviously it becomes much more powerful once you convert it to a native Tekla object.
Mm-hmm. And so you can see that what's highlighted in the model is what Tekla converted, but it also generates this report of converted parts. And so it tells me what the initial profile was. So this is the conversion between the two different programs. and then the profile that it converted it into, and it has the IDs. So with that, I can select them here, and it'll highlight in my model if I wanted to see what's going on. So that's there converted into native objects within Tekla, and I'll go ahead now and hide the IFC file so that we can see what remains. So these beams right here and everything are actual native objects within Tekla structures.
Looks good, Lee. I mean, what really blows me away with this is how quickly you can create an estimate or create a model just by doing the takeoff that you need to do already. Creating it from a manual takeoff, yeah, I mean, you'd look to have like some training for an estimator or something like that, but it doesn't have to be rocket scientist. Point-to-point lengths, ortho snaps, there's tracking, there's a whole bunch of other stuff that can really speed up that process. Using that 2D drawing as a template is fantastic if you can get one that's reliable enough. Again, really speeds up that takeoff process. Couple of things though, remember that when you get AutoCAD drawings or any kind of CAD drawing, they generally stop the lines short of the supporting member, so you need to watch for that little gap there and make sure you fill that in. Use the geometry point snap so you can snap to the DXF or DWG file, and use that snap to line for one-click conversion as well. Makes you really effective, really quick at building up that three-dimensional model from either 2D plans on paper beside you or a DXF or DWG file. The next thing you can do is you can import a three-dimensional model. The older format, the SDNF, Structural Detail and Neutral file, which was kind of more popular towards the industrial and process engineering guys, but you still see it coming from some of those softwares as well, and if you're in that industry, there's a good chance that an SDNF file exists. The other one, a sys2 or a step file it's sometimes called, popular with a lot of the analysis applications used by engineers, and they import as native objects in Tekla, so it automatically converts into a Tekla object. The newer one, the IFC, the one that the architects and the AISC and everyone is really pushing right now, is this industry foundation classes. You can use it in its raw form, if you like, for estimating quantities to be run from property sets. All that data is already in there, or of course you can use the native converter or the object converter that Lee just showed in there as well. Finally, the other thing, or the real key point here, is to ask for a model. We live in a boom world now, so let's try and get as much benefit as we can. How much time do you spend building models or doing takeoffs for an estimate? If there's already a model made, perhaps by the GC, perhaps by the engineer, perhaps by somebody else, see if you can get a hold of that. If you can get a hold of that, then imagine how much more quickly you can put an estimate together. Get the model, run the reports, get the information out there, and you can get your estimates in really quickly. If you can get the estimate in quickly, then you stand a better chance of getting the job quickly, I assume. We do, just on a side note here, we do produce this interoperability document, which lists Tekla structures compatibility with all the other softwares out there that say they talk BIM. So that's on our website there, on the solutions page on our website. Go ahead and download that. If you can't find it, just let Lee or I know. What we'll do next is we'll go on to just organizing the model ready for an estimate, so I'll hand you back to Lee for that.
All right. So what we'll talk about next is we'll go ahead and organize the actual model. What we'll use is the model organizer, which is a tool within Tekla that will allow us to divide the model into two categories: logical areas or object types. Logical areas would be like if you wanted to divide the structure up by floor, so level 1, level 2, level 3, or sequence 1, sequence 2, sequence 3, or whatever. The point of that is that an object in Tekla can only belong to one logical area. So the beam on floor 1 couldn't be put, if it was already in an existing logical area, couldn't be added to another one. Now with the object types, you can kind of mix and match those. So you could have, if we had levels 1 and 2, we could have object types or different categories into the specific levels.
So a beam can be a beam and a column in an object type, but it can't be in phase 1 and phase 2.
Right.
Okay.
Right. That clear as mud for you? When we get into the model, it'll make a little bit more sense. So what we're going to do is we're going to create object types and label them cost codes so that we can assign different items into different cost codes. So here on this slide here, you can see just some general cost codes of how the structure could be broken up, and then you can assign it a specific dollar amount. So for major structural assemblies, it's going to cost this much to fabricate, as opposed to like just simple beams and bracing. So what we're going to do is go into the model and create these sample cost codes, and we'll put the different steel into those so that the model is organized based upon these. That way we can quickly generate our estimates and assign dollar values to these specific things. Okay? So I'll go ahead here and hop back into the model, and I'll just close down this view right here and go ahead and open up. So here's the office. This is the structure that we're going to be working in. So to open up the model organizer, I'll just go to Tools, down to Model Organizer, which will open up this. And again, you'll see here the logical areas and the object types. So the logical areas would be floor by floor if we wanted, or sequence by sequence. But we're going to use the object types so that we can have beams on different floors associated to the same cost code. So I'll just come in here and do new object type. I'll create 4 of them, and then we'll go ahead and name these. So the first one, I'll just go ahead and rename this. So this will be cost code here, and I'll just call this major assemblies. Use some basic ones, and I'll rename this one.
So these could be like your own cost codes that you're perhaps using in your estimating systems right now. It could be a number or a like some kind of designator value for any of these things. So we're just using some examples here, 4 examples to highlight the possibilities.
Yeah, and more than likely you're going to have more than these, and probably be more specific about what is basic structural or what is miscellaneous. You could break it up into stairs and handrail or ladders. You could drill down as deep really as you wanted. So let me just go ahead and finish creating this one. We have
one of the questions coming in there, Lee, is if you can have subcategories of these cost codes. Is that possible too?
Yep, that is possible. You just select it and then just go in and create a new object type underneath that. So you could have major assemblies, and then you could break it down even further, columns, beams, or under the miscellaneous, like I said, handrails, stairs, ladders. Break it down however deep that you want. Okay.
And keep those questions coming in. We see some questions coming from a few of you. If you haven't asked a question before, please take this opportunity to ask one now.
All right. So what I'll do just to quickly create these categories is I have some selection filters that will allow me just to quickly lump this in. And you may wonder why use selection filters to get things into the model organizer, but you'll see that once we get going here. So I'm just going to go ahead and load this. This is just the little catwalk area, and I'm going to put this onto my major assembly. So this is a catwalk here that's going to be basically one unit that's going to require some special care. So I'm just going to go ahead and right click on the major assemblies and go down to add selected to category, and that shows me that there's 19 objects that have been added to that. So one advantage of using the model organizers now is that I can come and select these. I can add other things to it, but if I come here and click on this, the show or hide objects pane, what this will show me are all of the objects, so all of the names, the grid locations, the profiles, the top level, the mark if I ran the numbering, material, and everything like that. So it's much more informative than just having a simple selection filter. Another key thing is that I can highlight multiple object types, in this case cost codes, at one time. So I could highlight the major assemblies and the heavy structural all at once, whereas if you're using selection filters that were saved, you would have to load those separately or make another selection filter to combine them, but you still wouldn't get all of this information that's being reported here.
Yeah, I mean, one thing is like, say for example, as an estimator, you want to know what the paint surface area is from for one certain group. There is that custom inquiry tool up there, which can show that stuff as well. And you can use the model organizer with the custom inquiry tool to kind of highlight all of that information.
Mm-hmm. So I'll just go ahead and minimize that and then continue selecting the rest of this. So let's see, we got, let's go ahead and grab our miscellaneous material now. And I'll go ahead and add this. So I'll just right click and say add selected to category. So it's going to go through and put all of those in here. So what we'll be able to do is once everything's organized into the model, we can select them by their category and assign dollar amounts based upon these specifics. So I'll go ahead and put these. You can see back here we have some stairs basically for an emergency exit back there, and then some handrail that's running along the actual catwalk. So depending on how much information you want to include into the model for your bid, you can certainly do that. So the next one that we'll have, we'll go ahead and do our heavy structural. These are some columns here that are going to be handled. Basically, they're going to have shop splices on them, so we're going to have those build out differently than the others. So I'll just go ahead and add these to the heavy structural section. And then the last thing that we'll do is we'll go ahead and add everything that's not in these into the basic structural section. So here's where I'll show where if I just hold down control, I can I'll select the major assembly, the miscellaneous, and the heavy structural, and I can now right click and I could say show only selected, or I can actually hide them if I want. So I'm just going to hide these from the model.
So you can get everything else?
Yep. So that way I can just come in and select everything else.
Okay.
Alright. So now that those are hidden, I can just come in here now and I'll just apply this filter here. And then that will allow me to select basically everything else that's not already in a cost code. And then I can come in and just apply it here to the basic structural. So I'll just say add selected to category. It'll go through and populate all of that. And then we should be all set. So the process that we're going to do after this is we've created a custom report and a custom objects IMP file, or a new user-defined attributes tab, where we can come in and put in what the material cost is going to be for my major assemblies, what the fabrication costs are going to be for my basic structural, what the transportation, for the delivery and further erection. So based upon these cost codes, I can then come in and assign dollar amounts and dollar values to this, so that we can generate this custom report and get a quick little bid from this model.
Yeah, I mean, I think the key thing to remember is that all you're looking at is a graphical database, so you can at any time add new fields and then add contents or attributes to that field. So it could be anything, material cost, fabrication cost, profit, tax, you name it.
Yeah, and this isn't supposed to be the one size fits all for Tekla. What we're showing you is a way that Tekla can be customized so that you can leverage your workflows that you're doing right now to better suit you. So what you see today isn't meant to be, oh, you have to do it that way. Hopefully it'll open up your mind and say, you know what, we could take some of these ideas and customize them to meet our workflow, and then we can be off and running.
Sounds good. Ailey, one other question coming in right now is about making the estimate a little bit more accurate by adding connections into the model. Can you maybe show something with that?
Yeah, so what we could do is, if you didn't want to go take the time to add in all of the actual, like, the detailed level connections, let's just highlight this area here real quick. For example, we'll just grab this small little sections that you could come up here to detailing down to our auto connections, And there's a couple things that you could do here within this dialog box. Is that you could put on just like simple clip angle connections depending on the scenarios in the model. You could put on actual shear tabs, so that'll give you the connections with the bolts. It'll cut the beams back and cope them out and everything like that. Or you could just put on the actual fittings. If you put on fittings, you can set this back to where, like, if you had a beam coming into a column flange, the way that we have it modeled in is point to point. So from the center of the column out to the end of the flange is basically just going to be extra. This is going to be junk material, right? It's going to be thrown away. So you could apply the fittings to have it cut back to all of the different faces. So depending on how accurate you want to be or what you want to show within your estimate, you could choose these. So if I'll just come in here and just throw on, let's just throw on some shear tabs. We'll just go ahead and run these connections here.
So that'll cut everything back to length, and it will also apply the shear tabs and the bolts required for this as well. It may struggle. I mean, this is a system that we've developed or that we've localized here for the Tekla for our Tekla users. But of course, if you had your own auto connection system, you could develop that yourself. It's basically just a set of rules that defines what you want to do where one piece of steel hits another piece of steel. Yeah, exactly. You're just defining rules that if I have a beam going into a column and it's a perpendicular situation, use this connection. If it's skewed, use this connection, or whatever. It just runs through the different rules. Now it might show, like, zoom in where those like the awkward skewed connections are, because there may be somewhere it might just give you something that's not perfect, but it should be enough for an estimate. And it's also like, it's not going to be the final detailed solution, but it will still give you a good value of information based on the rules that you guys specify. That will give you a fairly accurate estimate.
Yeah. So your beams will be cut to length and everything like that. So depending on how detailed you want to get, you can most certainly do that. Okay. So let's go ahead now and we'll take a look here at the IMP file that we created. So I'm just going to double click on one of these beams, bring up my user defined attributes here, and I created an IMP file that created this estimating tab. So within the estimating tab, I have material costs, and that's broken down into dollars per ton. Fabrication costs I have broken down into dollars per foot. Erection costs, dollars per piece. Delivery costs, dollars per ton. And then a profit category.
Now, there's a couple of things as far as the INP file is concerned. We do cover it in our, do we do it in basic?
No, not so much in basic, in advanced.
So we cover it in our advanced training courses, editing the INP file. But there's also a tool on the extranet right now which allows you to create these user attributes. And we use this tool just to make a very simplified example for the estimating purposes.
Yeah, and again, not to beat a dead horse, but to stress that if you guys are, if you do your material costs or your fabrication costs, let's say you do it dollars per ton instead of dollars per foot, you can just come in here and tweak it. It's not limited or locked down to this, but just to kind of, we threw in dollars per ton, per foot, per piece, and then again for ton, just to show different capabilities that you can do within the report. So when we do our delivery costs, we're calculating the tonnage, and then we're dividing it by the weight that a truck can carry.
Like 20,000 pounds or something?
Yeah, 20,000, 40,000 pounds. So then when we generate the report, it'll show you actually how many trucks you need. Nice. So just to kind of open your eyes as what can be done with that, okay? So let's go, now we have this open, and let's go ahead and start assigning actual dollar figures to this to generate an estimate. So I'll just zoom this out here so we can see. Let me situate all this. Okay, so let's go ahead and let's start with major assembly. So I'm going to right click on this and say select in the model. So it's going to go ahead and highlight, actually we hid those, so let me redraw my view and bring them all back in, and that way we'll be able to see everything more clearly as we're assigning values to them.
Okay, let's take a few seconds. Yeah, just while that model's redrawing, it's something that people talk to us a lot about, like the potential for estimating in the model, and hopefully this will be something that like I said, it's not, or like Lee said, it's not supposed to be a be-all, end-all solution, But if you've got other ideas, then please let's hear about them as well. If there's something that you particularly do in your estimating that you think Tekla can help with, then please let's hear about it.
All right, perfect. So now that that's redrawn, let's go ahead. I'll just come in here and say select in the model, and it should highlight these columns here and here, and then in the back. So let's go ahead. Oh, sorry, I did major assemblies. Okay, so I got the catwalk highlighted. All right, let's go ahead and start with that. So let's go in for the major assemblies, and again, these values aren't exact. They're not meant to be exact, and I'm just going to basically just put in some values here. So whatever you guys would prefer to do, by all means, go ahead and do that. So we'll just go ahead and put in some dummy values here, and I'll go ahead and hit modify. So it's going to modify these to those pieces. Alright, so now that we have the major assemblies, let's go ahead and select in the model all of our miscellaneous items, and we can apply the figures to those. So I'll go ahead and select those in the model, and we'll go through and populate all that, and then I can just edit these values here and hit modify. So let's go ahead and wait for these to get highlighted here in the model, and then we should be all set.
Do the miscellaneous before, yeah. Is that done already? There you go.
There we go. Okay. So for the miscellaneous, I'll just go ahead and just adjust these values just so we can see how everything behaves. And I'll just put this in at 550. And I'll just go ahead and hit modify on those to assign these UDA attributes to those. Okay. So we're done. Major assembly, we got the miscellaneous. Let's go ahead now to the basic structural. I'll say selected model, and this is going to highlight the big chunk of what we have, and as Ian and we talked about before, that you could break these up into subcategories. So under the basic structural, you could then subdivide that further into beams, braces, columns, angles, or things like that, however you want it. So I'll go ahead, let's go 800, we'll do 35 on this one, 40, and 500.
Hey Lee, do you think we're going to win any jobs with these prices?
Probably not. It's not supposed to be close or exact. We don't want to reveal any trade secrets by our dollar amounts, so We'll leave that up to the experts.
Is that why we didn't put detailing rates in it?
Yeah. And I'm not putting any profit. I'm breaking even. Out of the goodness of my heart, I'm willing to do that for you. Alright, let's go 855, 55, 80, and 600. Go ahead and hit modify. Okay. Actually, since those... Let's do this. Let me make sure that works. Columns, make sure I got this applied. Okay, beauty. So now we have all of our cost codes. We created our cost codes. We assigned dollar values to every specific area. So what we can do now is run this custom estimating report that I created and take a quick look at what our estimate is going to be. What I'm going to do now is open up the template editor just to show you the template, the custom template that I created, just to show you some things that can be added. So let me just go ahead and browse this if you want to see kind of under the hood what's going on here. Let's go, I don't know where I had this. Let's see. Here we go. So this estimating.csv.rpt. Okay. So basically what we have here is I have these different headers. So we're going to see the material cost, fabrication cost, erection cost, delivery cost, and then it's going to bring in all of my different cost codes underneath those sections and then give me the dollars per ton. So in here you can come in and add any value fields that you want. Anything that you input into the model you can extract through the template editor. You can put in text to create those. You'll notice that you'll see all these commas that I have here, as I created this in a comma delimited format so that I could open it up into Microsoft Excel or OpenOffice and have it separated into different tabs and things like that. So this is just kind of, I won't go into too much detail, but this is basically what I created to be able to do this. So.
And once again, that's something that we cover in advanced training. If you want to come to advanced training and learn about how to create these templates, then we'd be happy to have you. Just contact your account manager and they'll get it set up for you.
So I'm going to run this estimating.csv, and I'm going to have I want it to open with the associated viewer. So I have Microsoft Excel set up to be my associated viewer. So I'm just going to go ahead and run this, and it'll open up Microsoft Excel and show us what we have going on. So let's there we go. I'm going to minimize this, and let me just expand some of these so we can see more what's going on within our actual estimate. So dollars per ton, there's the actual values here, and where's my cost codes? There we go. Okay, so this is bringing in just a simple, it says estimate worksheet, the project name, date, and everything like that. And then right here, so what I have is my material cost, fabrication costs, erection costs, and I have it build out what the actual values are. So for my structural, I have $800 per ton, and then it's multiplying that by my tons, and that's giving me the actual cost over here. And then it's just doing the same for fabrication, so it's taking the dollars per foot, so it's calculating the feet that are within the basic structural, multiplying it by that dollar amount and giving me the value there. Then I have the basic structural, this is dollars per piece, so I have the quantity here, the length, the weight, and then right here what I have is what I did for the delivery cost is I took the total tonnage divided by 40,000, which a typical truck can hold, and then it's telling me how many trucks I'm going to need for this material here. Okay, so I have those all subcategorized: delivery costs, erection costs, and etc. And then I have a grand total down here at the bottom. So that's basically what this report is designed to do.
So the other thing that you could do is, like, many estimators are very familiar with like programs like Microsoft Excel or any other spreadsheet application. One way that you could do it is you could even just extract the information from the model without creating any like as complex a template as Lee has done. But if you know Excel, you can dump all the information into Excel and then handle it or post-process it within Excel or within a spreadsheet application. If you wanted to as well. So, but the key thing here is just using the features within the model, getting the information into the model, and then getting that output back out in a usable format that you can then add prices to. Okay, looks good, Lee. If we want to just jump back to the PowerPoint, we'll just do a quick review on everything that we've done in this section of it. We talked about organizing the model, using the cost codes, making up the cost codes of your own, and using even the model organizer to assign those cost codes. So that you can get everything sorted and organized properly. The next step, of course, is preparing the output, and there's really three parts to this. Get the cost centers, if you like, or the items that you're going to build, like material, fabrication, delivery, erection, profit, tax, you name it. All of that stuff into the interface, if you like, or the user-defined attributes by editing the INP file from there. And then finally, the part that was really the most work for us was making that customized report. But like I said, if you're using Microsoft Excel, then you don't have to do so much work there. If you know Excel pretty well, dump it all out into a file in Excel and then manipulate it from there. So again, just a quick review on that. Run the estimate report in Tekla Structures. It could be a document-based output if you wanted, like the text report that we did from the template editor. Export that as PDF if you want, or a document. A spreadsheet application in CSV or comma-separated values file format. But also don't forget that if you're using any MIS or MRP applications, FabTrol, FabSuite, both very good at that. We do have dedicated links to that. And we also just recently, we've been kicking around this KISS estimating export, which is a very fundamental or very basic material dump to the FabTrol system, for example. But a good example there. So just in a summation, really, ask your GC or ask your engineer for a model. Don't be shy. Make sure that you can get a model and get all the benefits from it. Organize it just like Lee showed. You can use a model organizer for that. You could even use basic model filters if necessary. Get the estimate out, and most importantly, make sure you win the jobs. Okay, so that's basically everything we've got for you today. We're going to finish on time for once. Just a couple of other points to note. If you want it, we're going to do a little more session in a bit more detail at our user meeting in sunny Las Vegas. Come to the Cosmopolitan Hotel in Las Vegas, which was detailed in part by none other than our very own Lee Snyder. So
it won't fall down.
I promise you it won't fall down. Should be good there. It's a brand new hotel. I'm excited to be going as well. August 11th to 13th this year, 2011, of course. Come along and say hi to us. Our next webinar is not what it says there. It's going to be on Wednesday, 13th July. Wednesday, 13th July. Our slide's out of date, and it's going to be on organising the model. Please go ahead and register for that online at www.tekla.com/US. That's all for now. Just once again to say thanks for attending. Really appreciate the feedback that we get on these things. If you've got any opinions or any ideas, please let us know about them. Again, I'll just sign off by saying this was presented by myself, Ian Coates, assisted by Lee Snyder, and just once again a thanks to Brian Raglan up there in the booth, helping on the technical side. Hope to see you again next month at the webinar, and perhaps even at the user meeting in August. Thanks now.